So I decided today that I'm just going to take a stab at just going through Ziglings and starting to learn Zig a little bit. It's been intriguing me to the point where it keeps on going through my mind. So we're going to go through a little bit and just work through it. Eventually, I don't know how far into this I'll actually make it, because yeah, there's 100 of them. But we'll see. We'll see how far we make it, and then after this, I'll probably have a little side project where we start building maybe Vulkan, a small little game engine in Zig, because I'm currently building C++ one, and I'm just curious how this is gonna look. So I've already done the first couple of these hello, where I just added this pub at the front and this standard, where I just uh, assigned it. All right, so it seems we got a little carried away, making everything constant. U and 8. Const values can't change. U is unsigned. 8 means the number of bits. That's fine. Foo, blah, blah. Yeah, sure. Foo can hold 8 bits. You can just do about any quantity that you can think of. Please fix this program so that types can hold the desired value. So this one doesn't, we don't want this to be constant, looks like. I changed it to what? Var. So I can put var here. Negative number, so we don't want this. This is a big one. So 314, I don't know these. 314, looks like I need this to be 16. 16, go up to 65K. That's not right, so I need 32 here, actually. And then negative 11, which I just take this unsigned off, and then we should be able to play that. Use const negative 11. Oops. It's I8. I gotta change this to I8. And that looks like it's correct. Good. And then we can print with a format thing with some arguments. There's the period there, unlike the period. The string may contain placeholders, and the second parameter is the anonymous list literal. Don't worry about this for now, with the values to be okay. Arrays. Let's learn some array basics. So we can var foo bracket array size. When Zig can infer the size of the array, you can use underscore for the size. You can also let Zig infer the type of the value. So declaration is much less verbose. Get values array using the array index. Okay. Const is going to cause a problem later. Can you see what it is? How do we fix it? Well, I mean, some primes, yeah, because this line changes the first prime to 2, which is correct. Individual lines can be accessed with what's that? Not important. Individual values can be set with the bracket notation. Yes, we did that. Individual can be accessed with the bracket notation. Fourth prime. Looks like we need to complete this expression. Use the example above to set the fourth element of the sum primes array. Use the len property like that to get okay, get the length of the array. Is that correct? Because I assume we're counting from 0. Yeah, that looks right. Good. Fourth is 7, 0, 1, 7. Good. First is 2. What? Yeah, because we made it 2. Okay. Arrays 2. Zig has some fun array operators. You can use ++ to concatenate 2 arrays. So we have 2 arrays. We can concatenate them with ++. That's interesting. We can also use inline arrays to repeat an array. Interesting. I've never had to do this, by the way. This I've had to do before. This I've never had to do. Comp time. So problem 1, please set this array concatenating to 2 arrays above. So delete. Please set this array using repetition. It should at 1,0,0,1,0,0,1 times 3. So it's what? Like this, 1, 0, 0, 1. That's all the problem. Let's see the results. We could print these arrays with leet 0, leet 1, but let's have a little preview of Zig for loops instead. For item in array, item, do something with item. I don't like when people use vertical bars for things. For leet in, so this is the number. So, okay. For item array, item. Okay, this is a for each. For n in leet, I guess. Bits, bit pattern for n in bit pattern. Okay, so let's just run this and see what this gives me. Leet, cool. 1,0,0,1,0,0,1. Yeah, that looks correct. Strings. Now that we've learned about arrays, we can talk about strings. We've already seen string literals in Hello World. Stores strings as an array of bytes. It's almost the same as doing this, but there's probably null termination at the end, maybe. I don't know. See what strings really are in exercise 77. Gross. Notice how individual characters use single quotes and strings use double quotes. These are not interchangeable. Okay. Const Ziggy, probably use array square to get the letter D from, so that's 5. Use to make it say ha ha ha. So like this. Use the array concatenation number to make Major Tom. You'll need to add the space as well. What can I do? Do they want me to do this? What's that notation? I'm trying to. U8. Can I do U8? Can I do that? I can probably just do something else, right? But maybe that's what they want us to do. To solve the problem, let's see our results. Ha ha ha, Major Tom. D equal U. D equal U. 5. 0, 1, 2, 3. Oh, I counted wrong. D equal D, ha ha ha, Major Tom. Okay, that's good. Strings 2. Here are the fun ones. Let's see. Was there a way of just adding a space? Like, I feel like I'm not able to do it, but am I able to do like const Major Tom 2? Can I do that? I can. Okay. Right, because this gets cast into a string. Okay. That makes sense. Because this gets cast into an array. But you could also make it explicitly make it array. Okay. To make a multi-line string literal, put // at the beginning of each line to make a code comment. Just like code comment with backslash instead. Oh, that's annoying. This is worse than C++, for sure. Oops. I want to do this one. Oop. So you play guitar. Okay. Yeah, that worked okay. The issue with this is that, so in C++ you do like let's say like a const auto my string is equal, and it looks like this, right? And this would be the string literal, like that, in C++. But maybe there's a way to do, well, this isn't a string literal. This is just a multi-line string. So, but even then, maybe string literals are different. We'll see. All right, quiz time. You'll have to think about this one a bit. Let the compiler tell you what's wrong. Okay. Const letters. All right, let's just see what the compiler says. I should probably play the correct one. Expected type expression is 36. Lang equal letters X. Start at the top. What is this nonsense? Okay. Use size is an unsigned integer type used for sizes. The exact size of a use size depends on the target CPU architecture. We could have used U8 here, but use size is the idiomatic way to use for array indexing. There is a problem on the slides, but use size isn't it. It's probably supposed to be a var because the size probably doesn't stay at 1. When you want to declare memory an array in this case without putting anything in it, you can set it to undefined. There is no problem on this line. Okay. Attempt to put zig into the lang array. We just created by indexing the array letters with the variable x. Right, letters with the variable x. As you can see, the above x equal 1 to begin. Trying to put z. So what? This would be x equal. Oh, x is already equal to 1. Yeah, and we're changing x here. And this would be 1. This would be 0, 1, 2. 0, 1, 2, 3, 4, 5. This. X in there. We want to print Zig. Program in Zig. Yay, that was easy enough. Now, I wonder if there's some fancy array indexing here where I can do like, if I do like letters.len, this will give me an error, right? Array index out of bounds. Yeah. Ooh, it actually lets me do it. It didn't give me an error. Fun. So I guess I would just do this, right? If I want to. And can I do -1 here? They'll let me do -1 indexing here? No, it has to be use size. Okay, so it's not like Python. Doesn't let me have fun. Okay. Anyways, we're done the quiz. Now we go if. Now we get to the fun stuff, starting with the if statement. If true, else. That's simple enough. Usual comparison operators. The important thing about Zig's if is that it only accepts Boolean values. It won't curse numbers or types of it. Okay. If foo equal 1. Okay. Now, I'm just curious. Can I, like, how do you cast in Zig? Like, are you able to do... Here, let's see if my const boolean foo equal no, that's not what I want. Okay, we'll see if I can learn it later. Like, is there a way to coerce it so it won't automatically coerce it, but can you coerce it yourself, right? If a else, so this is like please use if else expression to set the price. So discount boolean if discount cool. Okay, so it is bool, but yeah. So like, I just want to look here again. Now I'm just, const is true equal bool 1. No, I don't know. Come back to it. If 2 is done. While loop. Zig while statements create a loop that runs while the condition is true. This runs at least once. This is very straightforward, all the same. So while, until, while, n smaller. Once the above is correct. All right. It might be smaller or equal, but it'll be easy enough to know. Yeah, good. Done. N equal 1024. Done. All right. While loop. I can have an optional continue expression which runs every time the while loop continues, either at the end of the loop or when explicitly continues. We'll try the while condition continue expression. Oh, interesting. So it's basically the same thing as, so like here we can do like that, right? And this would have done the same thing. Yeah, okay. Interesting. That's actually very handy. I like this. Please set the continue expressions that the desired result in the print line statement as in and okay. Oh. I just went back and did it manually myself. But yeah, so it's the same thing. While 3. The last two X's are functionally identical. Continue expression really show their ability when used with continue statements. While condition continue expression if other condition continue. The continue expression executes every time the loop restarts, whether the continue statement happens or not. I want to print every number between 1 and 20 that is not divisible by 3 or 5. I mean, I didn't even, like some of these I don't even have to think about just because it like, there. Done. I wish there were like tests to tell you if the output is correct in the Ziglings thing. But I assume that's correct. But that's basically what it is. It's just showing off that if you hit continue here, it will continue to press 1. So this becomes like a for loop essentially. For if n equal 1. Yeah. This is basically just a fancy for loop. But there's probably other uses for it. While for var n, you can force the loop to exit immediately with a break statement. Okay. Oh dear, this while loop will go on forever. Fix it, go below. Print statement below gives the desired output. We want n equal 4. So while true, if n equal 4, break. Right? Yay, easy. For loops. Behold the for loop. For loops let you execute code for each element of an array. For in story, scene, for scene and story. A thing called slices, which we'll see later. Also note that for loops have recently become more flexible and powerful 2 years after this exercise was written. More about that in a moment. Okay. Happy, happy, sad, okay, happy, the end. Okay, cool. Happy, sad, neutral, I see. Yeah, that makes sense. For 2. For loops also let you use the index of the iteration. A number that counts up with each iteration. To access the index of the iteration, specify second condition as well as a second capture value. You can name item and index anything you want. I is a popular shortening of index. Yeah, cool. Bits of, yeah, whatever. We're making an array. This is our iterator. Value. Bits. What's the second one? Bits 0. Binary bits to a value by adding the value of the place as a power of 2 for each bit. The 2 dots? It's 2 dots. What the hell are the 2 dots for? Maybe I should have read that. You can name item. You can also let you use the index of the iteration number that counts up. Oh, so this just tells you. So this is starting index. Counts up with each iteration. Second condition. Bit. We do that. Value of bits 1001. 13. Is that correct? 1, 4, 8, 9, 16. That's not correct, is it? That feels wrong. Because that feels like 16 plus 8, 24, 25, right? Shouldn't it be 25? Binary to decimal. 1, 0, 1, 1, 1, 0, 1. No, it's 13. Oh, 2. No, 2, 4, 8, 16. What? Am I dumb? Am I being a dum-dum? Oh, yeah, I'm dumb. I am being a dum-dum. 8 plus 4, 12, 13. Okay. I'm just dum-dum. I don't do binary enough. Quiz. Quiz time again. Let's see if you can solve the famous fizz buzz. Players take turns to blah, blah, blah. Import. This is not right. What is this? Like import. Like that, right? Pub function main, right? Is it func? What is it? Pub fun. Okay. Here, let's close everything else. Let's just keep this one open. Close all the tabs. All right. So it's fun, pug, fun, main void, right? Now, what kind of loop is this? A for a while. This is while. Debug print. Fizzbuzz. No. Oh, what is this supposed to do if it's just a number? All right. If it's not, then we just print the number, right? So I like that. Right? Is that correct? That looks about right. 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz, 16. Okay, yeah, that worked. That's correct. I looked at I compared it with this thing here, which is fine. The only difference I see here is that in the Wikipedia article, they're putting a space between fizz and buzz here. here. But we don't need to do that. All right, done. FizzBuzz is complete. Functions. We've already created a bunch of functions called main. Now let's do something different. Foo function. Okay, this is creating a creating functions. Simple enough. All right, so fun, and this is U8. Should return number 42. See below. One thing we're not missing is the keyword pub, which is not needed here. Can you guess why? Probably because it's inside the same file. It's file scope, I guess. Oh, we'll get to it eventually, I'm sure. Where's the next quiz? Yeah, so I'm going to do up to quiz 3 here, and then go do some other stuff. And then next time, I guess we're going to start working through all these error stuff. Answer to all the question is 42. All right, functions 2. Now let's create a function that takes a parameter. Here's an example that takes 2 parameters. As you can see, parameters are declared just like any other type, name type, whatever. 2 to the 1 to the, okay, 2 to the, looks like U32. So it's my number. 2. Yeah, I think that's it. 246, 248, 16, 248, 16. Yep. All right. Now, quiz 3. Let's see if we can make use of some of the things we've learned so far. We'll create 2 functions, one that contains a for loop and one that can turn into while loop. Both of these are simply labeled loop below. My numbers, print powers of 2, my numbers. 2 to the, okay. Okay, you won't see this every day. A function takes an array with exactly 4 U16 numbers. This is not how you would normally pass an array to a function. We'll learn about slices and pointers in a little while. For now, we're using what we know. Function prints but does not return anything. So this is a void then. For loop, numbers, loop. This is for like that. 2, this is 2 to the last, but don't fool, this one does the math without the aid of the standard library. So this is U32. This is a while loop. And we're returning the total. Right? That looks correct. Yep, that looks right. 5, 6, 7, 8. Yes. Now, how long is this video? This is a 30-minute video, so that's going to be everything for this little foray into Ziglings. I will continue this in, I don't know, week. I'll try to make this slowly work through this together, and then we'll yeah, and then we'll see how we go, and we'll build something in Zig. But so far, not too terrible. I'm enjoying it. I think Ziggs is interesting. Things I don't really like. I don't like this fun here. I wish I could just like, I get why it's there. It's because you got the types after, I guess. But I wish I didn't need to tell it that it's a function. I wish it could just infer that it's a function. C++ does that. I don't like the fact that I have to use a var and the type keyword here when I could, like in C++, like it would just be like type. So it would be like U16 total equal 1. So it's less verbose, and you would make it a const if you wanted it to be. So I don't like the fact that I have to type more. I don't like, I personally don't like the colon type syntax that's being used in a lot of languages. What else? This is handy. I like in the while loop this little thing here. That's very handy, and the fact that it gets called whenever you use continue as well. So if I put a continue here, it's functionally identical, but it if I break early, it will still increment this value. I think that's incredibly handy. Hmm. What else? Standard. We haven't really got into the standard library too much. And this is just kind of standard. I imagine there's a way to put args in here. Arrays. Let's see. Arrays. What do I think about arrays? It's not the same. I think array syntax becomes a little bit more concise. I think in this format, built-in length operator, the array operators themselves, the built-in concatenation and multiplication, concatenation specifically, I think could be quite handy. I do a lot of that. C++, which I have to use library functions for. Strings, I actually do like the fact these strings are essentially just, and I don't know, I want to look at 77 at some point. 77 sentinels. Null terminated. Okay, yeah. Null terminated. Just like C. They're C strings. Yeah, so basically the strings are essentially just C strings under the hood, which I do like that. If statements, they're typical. If else, I do like the if else better. Actually, I do like my question mark in C++. I like my ternary in C++, because I don't like writing if here, but it is easier to see at a glance what's going on here. So this is probably long-term better. Yeah, and obviously not having to import another library to do logging like this, that's nice as well. Anyways, that's my thoughts on Zig so far, and maybe we'll continue. Well, we will continue this another time, just not today. I'm gonna go do something else now. See ya.